I'm Sarah, I'm a high school senior, and I'm here today to talk to you about gravitational waves. So let's say you're in a pool. No, bigger. No, a really big pool. There we go. You're floating in one end, just doing your thing, when all of a sudden your annoying kid brothers at the other end of the pool start splashing each other. Even though they're all the way at the other end, what happens? Well, one, they get yelled at by the lifeguard, and two, they make waves. These waves travel through the water, and since you're all the way at the other end of the pool, they take a while to get to you, and they're pretty dang small by the time they get there, but you still get hit by these waves. Let's look at the same situation, except this time you are still yourself, but your brothers are colliding black holes, and the pool is the universe with gravitational waves moving through it. Wait, what? This happens on the scale of the universe? Let's look at these three parts of the situation individually, starting with the universe. Just like we say a pool is made up of water, which waves move through, we can describe the universe as made up of something called space-time fabric, which waves also move through. What does this mean? Well, space you already know about, the three physical dimensions in which we exist. Wave your hand around, you're moving it through space. Time you also already know about, a single dimension in which we also exist, and that you're moving through as you sit here and watch this video. What about the word fabric here? Do space and time together make some sort of cosmic cloth? Well, space and time together aren't actually a fabric in the same way your shirt is. You can't reach out and touch it. We can use the idea of fabric here to describe the four-dimensional continuum created by space and time together. In this conceptual fabric, space and time are interwoven. The 4D shape of this fabric can be warped by gravitational forces. So can we really compare four-dimensional space-time to water in a pool? Well, they're obviously quite different, but this is a useful comparison because just like waves travel through water, waves of gravity can travel through space-time. How does this work? This brings us to your brothers, or the black holes. Black holes are cosmic objects that are so dense they exert a very, very, very strong gravitational pull. It makes sense that when two objects with such a strong gravitational pull collide, this collision has huge gravitational consequences. Specifically, this collision creates gravitational waves, which, just like waves in water, move outward from the point of collision, through the space and time of the universe, causing ripples in that space-time fabric. What about the most important part of this situation? You. Well, we already established that you exist in space and time, so when waves ripple through space and time, it makes sense that they have an effect on you. In the pool situation, the water moves you around. In the universe situation, the fabric of space-time moves you around in the dimensions of space and time. Let's recap. So, like we can describe the pool as made up of water, we can describe the universe as made up of space-time fabric, which can be warped by gravity. Colliding black holes far away from us create huge gravitational waves that move across the universe. It's important to note that all gravitational interactions create distortions in the space-time fabric, but we're talking about the collision of black holes here because that distortion is big enough for us to detect. You might be wondering, 1, does space-time actually warp, and 2, how do we know? 1, yes, this does actually happen, and 2, how we know has to do with a couple of isolated labs, a bunch of scientists, and a laser, and a couple of mirrors. At these labs, there are lasers, receptors, and mirrors set up like this, with very precise distances between everything. The laser beam is split between the two arms of the same length, bounces around on the arms, and returns to the receptor. With these lasers, we monitor the lengths of the arms. Because these distances are so precise and secure, and because the lab monitors for outside disruptions, like trucks going by, under certain conditions, a change in this distance can tell us that spacetime has warped. 1.3 billion years ago last February, two black holes collided, resulting in gravitational waves across space and time that were then detected by both of these laboratories 1.3 billion years later. The space between the lasers and the mirrors shifted very, very slightly and then shifted back in a way where a wave in spacetime was the only possible explanation.